All right, collisions using zero momentum frame. It says, two balls are rolling towards each other. Ball A has a mass of 4 kilograms. And a velocity of 2 meters per second. Ball B has a mass of 1 kilogram. It has a velocity of -3 meters per second. And then make a sketch, done. Letter A, it says, what is the total momentum before any collision, before the collision? So we know that momentum total, so we got, if momentum total is the momentum here plus the momentum here. So the momentum here is gonna be that, so our momentum is, oh sorry, wrong thing. Our momentum one is gonna be mass one, velocity one. And my mass is 4 kilograms, and my velocity is 2 meters per second, so I've got 8 kilogram meters per second. Okay. Now, my momentum over here is gonna be 1 kilogram times 3 meters per second, so 3 kilograms. Okay. Boom. All right. So that's as A and B. Now, if we view the motion of the balls from the viewpoint of the center of mass, this is called the zero moment frame. So our center of mass is probably somewhere in this area, closer to our heavier one. So we're viewing this from our zero momentum frame, the center of mass. So viewed from the ZMF frame of reference, how fast are the two balls moving? This is how you find that out. The first thing, oh, I forgot to do B, you guys. Okay, sorry, go back up here. So the first thing I have to, I jumped the gun here. What is the total momentum after any collision? Let me go ahead and add these up together. Where's my black one? Here we go. Okay, so an 8 plus a, oh, and you guys, I forgot negative. -3 right there. Okay, 8 plus a -3 gets me 5 kilograms meters per second. Okay, that is my momentum total. Okay, we'll come back to it. And then I forgot to do B. What is the velocity at the center of mass? I'll do it in this. So the velocity of the center of mass is m1v1 plus m2v2 over mass 1 plus mass 2. Now m1v1 is just this, 8 kilogram meter per second, plus -3 kilogram meters per second, or of course 5, divided by mass 1 is 4, mass 2 is 1, so 4 plus 1 is 5 kilograms. So this whole top thing is 5 kilogram meters per second over a 5 kilogram meter per second. That gets me 1 meter per second. Okay, so the velocity for my center of mass is 1 meter per second. So this was A right here, this was B. I jumped the gun on that, sorry. Okay, so now if we view the motion of balls, both balls from the viewpoint of the center of mass, we call this the zero momentum frame. Viewed from ZMF frame of reference, how fast are the two balls moving? So in order to do this, we're going to subtract the velocity from the center of mass from the velocity of ball A. So the velocity of ball A, let me just make sure you guys can see this okay. Yeah, that should be good. Okay, so the velocity of ball A, okay, was a positive 2 meters per second. And we're going to subtract this from that. And we're going to get 2 minus 1, 1 meter per second. Okay. So we subtract the velocity for the center of mass from ball A, and we're going to do the same thing for ball B. And also, ball B is blue. Knew that was going to happen. So ball B is -3 meters per second minus 1 meter per second, and we get a -4 meter per second. Okay, so we subtracted the velocity for the center of mass, which is right here, from the velocity of ball A and of ball B. These are the velocities the ball will have moving toward each other from the point of view from the ZMF. What that means is that this 4 kilogram ball, when looking at it this way, the B ball is coming at it at -4 meters per second. And then as I stand here, if I'm the B ball and my center of mass is right here, I'm looking this way, the A ball is coming at me at 1 meters per second. Okay, so after the collision, the two balls will move apart from each other with the same speed but exactly the opposite direction. Make a sketch of the two balls after the collision in the ZMF with the signs reversed. Let me just check to make sure you guys can see okay. Okay, good. All right, so now we have ball A. Or actually, let me not draw that circle right there. Okay, now for ball A, 4 kilograms, it's going this way. And ball B of 1 kilogram, it's going that way. And it just says to reverse, make a sketch after the collision in the ZMF with the signs of the velocities reversed. So now instead of 1 meters per second, it's just -1 meters per second. And then over here, in fact, let me go ahead and draw that in purple. Now it's -1 meter per second. And over here, we've got +4 meters per second. I take this and I switch the sign because they've collided and now they're going in the opposite directions and the velocity is unchanged. Now let's return to the lab reference frame by adding back the ZMF velocity from the center of mass to each velocity above. Make a sketch. What have we just done? Okay, so what that means is we are now going to come back here and we're going to add this here and we're going to add that here. So if I add 1 meter per second here, I get 0 meters per second. If I add 1 meter per second here, I'm going to get 5 meters per second. We now have solved for both of the velocities after the collision. We have solved for 2 unknowns. Check by finding the total momentum after. Check by looking at my solutions on the board. Here's my solution on the board. So basically, our momentum total was 5 kilograms meter per second. And over here, if I was to plug this in, mass excuse the interruption. They do this every day. It's kind of funny. So mass is 4 kilograms times my velocity is 0.
What the rest of that was, but that was the Twilight Zone theme. For all you millennials, that's a black and white TV show, although there was a remake.
I'm gonna keep going.
Please sign into your COVID form. As soon as you get here, have a great Thursday.
Okay, we'll keep going. So over here, my mass is 4 grams and my new velocity is 0 from the ZMF frame. This gives me 0 for my momentum. Over here, my mass is 1 kilogram and my velocity is 5 meters per second, which gives me 5. Okay, now we take a look at this. 0 plus 5 gives me a total momentum of 5. Can you guys see that? Sure can. Kilogram meters per second. Okay. So what this means is we get the same answer, right? When we do it like this, we get 5 for our total momentum. And when we use the ZMF reference frame, we also get 5. So that's how you check your work, and that's how you do it.